Tuples are essentially immutable lists. They are more efficient than lists in their use whenever you don't expect that you're going to modify the content of a list, or you want to actively prevent the user from modifying that content. For instance, in the case that you're listing nucleotides, it's unlikely that anyone may want to change these. So you can index through a tuple pretty much as you would index through a list, or you can find the index of an element in the tuple as you would with a list. But if you try to assign to a tuple, that will cause an error message to appear, and the error is tuple object does not support item assignment, so you cannot change the items. If you look at the directory of the methods of a tuple, you will see that all the things such as remove, append, extend are no longer there because you're not allowed to change the tuple. Now this is slightly confusing because this behaves differently from what you would expect for lists. So if you remember this example above, when we have a list and we assign it to a new variable, that's actually the same list. So any modification of list B is actually a change of list A. If we change B, we're also changing A, as we have seen. But see what happens here. We define a tuple, we assign it to another variable B, which is another name for the same tuple. And then this seems to be changing the tuple, but when we look at them, we see that A has changed and B is the same. Now, obviously, the explanation is that A has not changed because it is an immutable object. So this does not do what it appears to do. What it really does is that it creates a new tuple that is the concatenation of 1, 2, 3 and 4, 5. This new tuple is stored in A, and the original tuple is still stored in B. So as long as you remember that you cannot actually change a tuple, it all makes sense.